In this session of sets, we are going to prove the distributive laws. So these are the distributive laws. A union B intersection C is equals to A union B intersection A union C and its counterpart, which has an intersection. So we're going to start with the first one. Yes, likewise, we're going to solve using normal algebra and sets. Okay, now in normal algebra, we're going to go back again to the basics and multiplication. These ones are the basic operations that we use for normal algebra, but like we said, in sets we use the union and the intersection. The union in terms of algebra is just the same as multiplication. The intersection in terms of algebra is just the same as a plus. So this will help us a lot to solve what we're talking about. Okay, then another thing that you're supposed to understand, so let me just write them here so that we shouldn't forget. Union, we're saying it is the same as multiplication. Intersection, we're saying it's the same as plus. On the other side, union is also the same as or. Intersection is just the same as and. Okay, so these are very, very important. We're going to keep them. Okay, now just the name distributive, meaning you are distributing. A common example that I can give, if I've got a 2 is multiplying with what is in the brackets. Let me say B plus C. When I'm going to distribute, this 2 is going to multiply with the B. Then after that, the 2 is also going to multiply with the C here. So that's how we distribute. And if I distribute, I'm going to have 2B plus 2C. This is according to normal distribution of equations or expressions. So that's what we do. But now, what about what we have on top? So allow me to use just the same simple algebra. I can let's say A is equals to, let me say 2, let's say B is equals to, let's say 4, C is equals to, let me say a 6. Okay, and let's try what we see, what we're going to get. Okay, so where there is A, I'm going to replace sequentially where there is B and C as well. So let's solve. So in this first equation, I'm going to replace these ones. Even in the second equation, we see if they're going to give us the same answer. So the left hand side, we want to see if it's equals to the right hand side. So let's start with the first one. A, I'm going to write, our A is 2. So I'm going to write 2. Our union, we said, is the same as multiplication. So I'm going to put my multiplication sign. B, we are saying it is a 4. I'm going to put my 4. There's an intersection. An intersection, we said, is the same as a plus. So I'm going to put a plus here. Then we have a C. A C, we are saying it is a 6. We're going to put a 6. Is it equals to? A, we are saying it is a 2. Union, we are saying it's the same as multiplication. B, we are saying it is 4. I'm putting this in bracket. Intersection, now our intersection, we are saying it's the same as a plus. I'm going to put a plus here. Then I have A again, which is 2. Union, we are saying it is multiplication. And our C is 6. Okay, let's solve the 2 if we see if we're going to get the same answer. So let me first solve what is in the bracket. So I'm going to say 2 is multiplying by 4 plus 6. 4 plus 6, we know that gives us a 10. Okay, then if I solve 2 multiplied by 10, that is a 20. So on the left hand side, we're getting a 20. That is the left hand side. When we come to the right hand side, I solve whatever is in the brackets. Then after I solve, I'm going to now add. Okay, so let me start with my left hand side. 2 multiplied by 4, that is 8 plus. Okay, then 2 multiplied by 6, that gives me like a 12. Okay, therefore I've got 8 plus 12. Now 8 plus 12, what does it give me? That just gives me a 20. This is the right hand side. Now you're able to see that the left hand side is giving us the right hand side. Hence we've proved the distributive law, okay, using normal algebra. Okay, so that's how you prove if you're going to use normal algebra. What if this time you want to use, just normal sets without involving numbers? How are you going to go about it? Okay, not very much different. We're going to we can just pick maybe x be a member of the same set. Let me say we're proving the left hand side to see if it's going to give us the right hand side. So let's say x is a member of A union B union C. Okay, that is the left hand side. So based on what we know, let me separate everything. So there are two sets, there is A and B union C. So I'm going to say x is a member of A and O, because we've got a union. A union we said is the same as O, so wherever there is union, I'm going to be placing O. Okay, then again I'm going to separate the other two sets. Okay, I'm also going to say x is a member of B. Here there is a union, so I'm going to put O. Is it? Okay, I think I've not copied the question correctly. So this here is not a union, actually it's an intersection. Okay, so we're saying this is intersection C. Okay, so that is the law. Okay, so when I'm distributing that, so x will be a member of B on the other side. Now there is an intersection. An intersection we say it's the same as what? And. Okay, so therefore I'm going to have and, then x now will be what? X will also be a member of C. Okay, now because of this and we have an A here, so this again I can expand it, because I know that A multiplied by B will give me AB, A multiplied by C will give me AC. Okay, hope you're getting the sense. I'm saying A multiplied by B, I'll have AB. The and in the middle, let me put it as N. Then A multiplied by C, I'm going to have a C, AC. Okay, that's what I'm talking about. So you have AC, N, you have AB, N, then you have AC, if you are going to distribute like that. So that's why I'm saying this last part we can also separate it in terms of A and in terms of C. So what are we going to have? Allow me to write it as x is a member of A again, or x is a member of C. That's how we've separated them. Now that we've got this, allow me to factorize this part and allow me to factorize this part differently. Okay, so let's start with this part. So when I factorize, let me factorize the x is a member of. So I'm going to factorize x is a member of because it's common on both sides. I'm going to remain with A. Our O we said it's the same as union, so I'm going to put union. Then here we've remained with B. We are done with the left hand side of this equation. Okay, then we've got an and. An and we said is the same as an intersection, so I'm going to put an intersection here. When I come to the other side, if I also factorize x is a member of, if I factorize x is a member of, what am I going to remain? Here I'm going to remain with A. I've remained with O. O is the same as what? O is the same as a union. Then I've remained with a C on the other side. So this is what I have. Then I can also again factorize. There's x is a member of and x is a member of. I can factorize those two. Okay, so I'm going to have x is a member of. Here I'm going to remain x is a member of A union B. There's an intersection, you don't have to forget it, so I'm going to write intersection. Then we write what remains. We have remained with A union C. This is giving us the right hand side. So that's how you prove the distributive laws using both algebra and sets.